To all the Encon managers and energy champions out there, greetings from Raghavan, ORPAC Systems, Pune. I have 38 plus years experience in air conditioning and refrigeration industry. We manufacture industrial process chillers and hot water heat pumps specifically for different industrial applications. This 8-part video series is intended to share my practical experience of applying heat pumps in a typical industrial environment. There are too many applications which are all exciting. I wish by sharing my experience of practically applying the heat pumps in industries, it triggers more thoughts in you and you are able to evaluate some of the available opportunities at your end to decarbonize and come out with some very interesting projects and outcomes. The topic for this episode is why in some of the heat pump projects implemented in industries, the actual accrued energy saving is not as per the intended energy saving. Normally we say compared to electric heaters, taking a 80 degree centigrade hot water output from the heat pump, very minimum 50% we should be able to save. Approximately few percent it could go here and there. But there are projects where the Encon managers have measured the energy consumption. They have data. They say instead of 50%, what we actually realize is only 15 or 17%. So that was quite sort of shocking to me and also make it a lot more inquisitive. Why at all such a thing should occur? So when I have done quite a few case studies. So here let me share with you one case study of what I found. So of course I won't be revealing the names. So there was one particular site with multiple tanks, one after another in the production line, process line. One of them was a 3000 liter capacity degreasing solution tank, which was being maintained at about 50 degrees to 60 degrees centigrade temperature using a 24 kilowatt immersion type electric heater. So the Encon manager, he had heard about heat pumps, it will save energy. So he was quite keen that I want to implement a heat pump project and get 50% energy saving. So he was in touch with one of the heat pump manufacturer. Through discussion, the manufacturer also informed him, compared to electric heater at generating 80 degree hot water, we do save about 50% energy. So when this project was implemented, he again took a measurement. He actually got only 17% of energy saving over electric heater. So they could not figure out why at all these things should occur. Now this made it a lot more interesting for me because there must be some valid technical reason. Otherwise heat pumps do not perform this badly. They give excellent performance. So when I got into the details, what I found was something quite interesting. So this degreasing solution was to be heated using a hot water from the heat pump. Now for whatever reason, it was agreed that a gasketed PHE will be used on one side and hot water will be circulated, degreasing solution will be circulated on the other side. That is how a tank temperature of 50 to 60 degrees centigrade will be maintained. So the Encon manager, he caught hold of one of the available local contractors, got all these things executed, putting a hot water thermal storage tank, required number of pumps, pipings and all that. How it went was something like this. The heat pump only was supplied by the heat pump manufacturer. There was a thermal storage tank which was built by the contractor with a partition, sort of hot well, cold well kind of a concept. So there was a circulation pump, let us call it primary pump, which is taking water from the thermal storage tank, circulating through the heat pump, putting the 80 degree centigrade water back in the tank. Another pump was used, let us call it a secondary pump for easy understanding. This is taking 80 degree centigrade hot water from the thermal storage tank, circulating to the gasketed PHE on one side of the gasketed PHE. Now there is one more pump, that pump, which is a degreasing solution circulation pump, which is near to the degreasing solution tank, taking the degreasing solution, circulating on the other side of the cascaded PHE. And because the tank was 3000 liter volume, which was using compressed air to generate gentle air bubble, mainly to ensure good mixing of water, sort of agitation to be provided. So they calculated certain number of water circulation rate per hour and all that. So they selected a 2 HP pump. Once a 2 HP pump was selected on the degreasing solution side to overcome the particular water pressure drop of the cascaded PHE, circulation rate, etc. Same model pump was used on the hot water side also. Because of the viscosity and all that concerned, the circulation rate and pressure drop was coming to be almost the same. Now, because this is a 2 HP secondary hot water pump, which is going to circulate hot water through the cascaded PHE, the primary pump also became a 2 HP, same size, just to match the supply and demand in the thermal storage tank from the supply side and demand side. That is how it happened. Now, what we have to understand here is, whenever a heat pump manufacturer give a catalogued product, okay, it generally doesn't include the thermal storage tank and the pump. What is the reason? Because the industrial applications are too many. They will require different temperatures, a different kind of thermal storage tank volume. They may have different kind of resistance on the water flow side. So what HP pump will be required? All these are difficult to predict. So usually the catalogued standard product from the manufacturer comes without a pump and a tank. So this is how the energy efficiency, COP value, while stated, is around, let us say around 2, could be 2.1, 2.2 something. Now we want to understand why the 50% dropped to 15%, right? So let us go step by step. If you take the compressor alone from the compressor performance envelope, the 85-degree hot water scroll, maybe compressor alone at the selected evaporating condensing temperature gives about 2.2 COP, approximately 2.2, 2.3. When you add the evaporator fan motor power consumption to this number, it may drop by about 0.15. Let us round it off to 0.2. So the 2.2 has already become 2 COP. No pumps, nothing else, right? So in the site, when we added one number of 2 HP circulation pump, roughly 0.3 the COP dropped. Because whenever we are talking of HP, we all know HP is only the output. So the input power is much higher than that, depending on the overall pump efficiency. So the COP has already dropped from 2 to 1.7. You add one more 2 HP secondary pump, another 0.3 it gets hit. So 1.7 becomes about 1.4. Then degreasing solution to HP pump also we have to take into consideration, because that also has been added new to the retrofit project. So another 0.3 it goes down. So compared to where we started, 2 plus, we have ended up at a much lower number. Now, as far as an Encon manager like you are concerned, what matters to you is not just the COP of the catalog product, it is what is the overall energy consumption of the total deployed system in place. So this is how the number went down. So there is a reason why it went down. If at all some of you might have calculated, done some maths, you may wonder, it is still coming to about 35% or 30%. Why from 30% it went down to 15, 17? The reason is, whenever we are making measurements, it is instantaneous value, right? So for heat pumps, the performance is continuously changing. That is why in one of my last episode, I recommended using a continuous thermal energy meter, which is also known as a BTU meter, and electric energy meter. So this can give you instant readings also and accumulated readings also. Like if the heat pump has run for 1 month, 6 months, 1 year, 2 years, it also store accumulated energy consumption on the energy meter as well as the total volume flow rate of the hot water. You know the inlet outlet temperatures. So even that accumulated thermal performance delivered is available as a data. So this usually helps to understand the overall system performance rather than taking one particular reading at this minute and then reaching to some conclusion. So usually this results in at least 10 to 12, 13% difference of stated COP and actual COP whenever we are making instantaneous measurement at site. Now you may ask me how you would have done the project differently. Usually when more than of course I do manufacture heat pump, but my focus is more on the application side. I ask the Encon managers so many questions to understand the application. In this particular project, if at all it is a degreasing solution, what I would do is, first I will evaluate the degreasing solution compatibility with material. If at all it is compatible, there are certain degreasing solutions I have directly taken into the shell and tube condensers that I use. So I eliminate so many pumps that are involved. So this way, at least roughly in this case we were discussing 0.3, it was coming down. So usually 0.6 COP I will be able to improve just because of that. Second thing is, in this particular case, the Encon manager had not still stopped the compressed air supply for gentle agitation of the degreasing solution. So that is one more thing I would insist with the Encon managers. Please shut off the compressed air supply to that tank, because already you are using a pump to agitate the degreasing solution. And next thing I would normally apply in my design is, I will be checking what is the actual water flow requirement, because in many of these degreasing applications I have seen, what we require is a gentle agitation. We don't need a turbulent flow with violent agitation of the whole solution bubbling. That kind of a flow is never required. So I will also usually look at optimizing the pump flow. This way, instead of a 2 HP, we can definitely reduce the pump power consumption. So these are the things normally I consider. Hope through this episode, at least you got some idea, some inputs to trigger more thoughts in your mind. So whenever you are actually thinking of doing a heat pump project to replace an electric heater or a LPG boiler or any other hot water system, do think of an integrated approach. Don't go by whatever is mentioned in the catalog. And many of the retrofit projects, you may not be using a consultant because it's a small retrofit project. We cannot afford to have a consultant. So do get into studying all these details before you deploy the total system there. So with this, we come to the conclusion of this episode. Again, we will catch up in the next episode talking about how do we make the heat pump a lot more successful. How do we get the full benefit out of the heat pump by using the cooling that is available free from the heat pump. So we come to the conclusion of this episode. If at all you like this particular series of heat pump, if you think this is helping you in any way, I request you to subscribe, share this particular video with the energy conservation group that you may be a member of, and share it with all your friends working for energy conservation who could be also ESG managers. If you have any queries, my coordinates are given here. So you can drop a mail or give a ring or send a WhatsApp message or post your comments in this YouTube video. Thank you so much. We'll catch up again next fortnight. Thank you.